Hello, am I audible? Hello, आवाज आ रही सबको आवाज आ रहा है मेरा? हेलो.
Yes, sir.
Yes, sir.
Okay, so good morning all of you. Today we'll start our lecture with आगे का portion जो भी है. In the last lecture we already had done the kinematics of rigid bodies, correct, no? So in that way we have already covered the kinematics part. In the beginning of the lecture, when we started the dynamics part, I had told you the dynamics has two subdivisions. Okay, one is kinetics and one is kinematics. आवाज आ रहा है सबको? हेलो हेलो हेलो.
Yes, sir.
या तो जो काइनेमेटिक्स वाला पार्ट है, मैंने बताया था आपको. इन काइनेमेटिक्स वाले पार्ट में जस्ट अ मोमेंट, इन काइनेमेटिक्स वाला पार्ट we don't consider the effect of what? The forces, correct, no? We only deal with the geometry of the motion, correct? Geometry of the motion. Geometry of the motion means we analyze only the motion parameters like displacement, velocity, acceleration. Displacement, velocity, acceleration, okay? Means we neglect the cause of the motions, correct? Cause of the motion, okay? Now here we have a kinetics, okay? So kinetics may we are going to deal with the analysis of particles or bodies, okay, by considering the cause of motion as well. Cause of motion, that means we are going to consider the force effect as well and the motion as well, motion parameters as well. Like for example, if I tell you this is a body, okay, which is under motion. So how much, let's say if it is in motion, so of course this will have some motion parameters, okay? So one can ask here ki what is the amount of force needed to produce this much motion, or you can say in reverse, okay? If this much force is applied, okay, what will be the amount of motion produced, correct? So this whole analysis comes under kinetics part. Okay, now when we deal with the kinetics, essentially this kinetics depends on the three different important principles. Okay, are you getting me? Hello, hello, are you getting me? Hello.
Yes, sir.
Yes, sir.
So essentially this kinetics depends on the three important principles. First is d Alembert's principle. Okay, or you can say the modifications of Newton's second law of motions. Okay, so here we'll talk about the Newton's second law of motion and D'Alembert's principle. This will be the first. Second will be the work energy method or work energy principles, you can say. Okay, essentially यहाँ पे क्या होगा? We will going to discuss about the change of kinetic energy. Okay, change of kinetic energy produced in the body, and we'll see this change of kinetic energy produced in the body, okay, how it will affect the motions. Okay, so this will absolutely based on the change in kinetic energy. And third, as we'll proceed, this third part will be the impulse momentum principle. Okay, impulse momentum principle. So this talks about the law of conservation of momentum, law of conservation of momentum. समझ में आया? तो इस तरह से आपका काइनेटिक्स जो है तीन डिफरेंट पार्ट में डिवाइडेड है. नाउ टुडे we will be entirely focusing upon this first part. Now any of the kinetics problem can be solved. Okay, listen carefully. Any of the kinetics का problem can be solved by any of this method. ऐसा नहीं है कि कोई भी kinetics का problem है तो सिर्फ ये पढ़ाया है तो यही मेथड से कर सकते हैं या ये पढ़ाया है तो इसी मेथड से, ऐसा नहीं है. Any of the kinetics problem can be analyzed with any of these three methods. But see, in some of the problems you will find that this one of, let's say you, if you have some problem, okay, let's say kinetic का some problem, okay, जहाँ पे आपको कुछ analyze करना है, like you have to determine the acceleration and all that. Okay, so वहाँ पे you will find that in some cases कि ये वाला method will be easier to analyze this, or this will be easier to analyze this. So it may so happen कि in some of the cases कोई एक method किसी एक problem के लिए बहुत best suit कर सकता है, means बहुत analysis बहुत faster हो सकता है. ठीक है, तो that if you are going to understand that if you are going to catch, you will analyze your problem very fast. Okay, and that habitual comes in you after practicing lots of problems. Okay, तो जब आप बहुत सारे problem solve करोगे then आपके अंदर वो automatically क्या हो जाएगा, capture हो जाएगा कि कौन से problems को किस method से deal करना ज़्यादा better है. But as I told कि any of the kinetics problem can be what solved with any of these three methods. Is it clear up to this? Hello, hello.
Yes,
So
sir.
today we will discussing about the kinetics of particles. Okay, no doubt, first part. Okay, and this will be the discussion on D'Alembert's principle. Okay, and Newton's second law of motion. Okay, right. Now, before going into detail, let me revise the few concepts. Okay, as you all know, what is Newton's second law of motion says. Okay, what is Newton's second law of motion saying? Yes, Newton's second law of motions क्या है? According to Newton's second law of motion, if suppose this is a body, okay, and if suppose it is being the body, okay, is acted upon by a several number of forces, let's say F1, F2, F3, okay, then there could be a resultant force, okay, this can be like this, okay, let's say delta summation F, okay, which will represent its resultant force, okay. Now the body may be performing a motion that may be rectilinear motion or curvilinear motion. So here we are normally going to consider the rectilinear only. Okay, so let's say it is our coordinate axis, that is x and y. Okay, so if the, if the resultant force, if we found that delta f or summation f, you can say, okay, and this several number of forces can be replaced by a single force, that is a resultant force, and if it is not zero, if it is not zero, okay, so if the resultant force acting on the particle is not zero, then what will happen? Can you tell? Yes,
It will move.
the particle will have an acceleration, correct, which will be proportional to the magnitude of this resultant, correct now, and it will be in the direction of the resultant force. So resultant force is in these directions, so this body will have an acceleration, and body have an acceleration in this direction, that means it will have some motion, correct, that will be given by m times a, right, right or not?
Yes.
Yes, this particle would move in the direction of result. Particle will what? Particle would move in the direction of resultant force. Correct. In other words, what we already have studied, आपने इस तरह से पढ़ा होगा, that is rate of what? Change of momentum. Rate of change of momentum. Okay, in your physics course, you might have studied like this. Rate of change of momentum of a body is nothing but given as what? The, or you can say it is proportional to the resultant force, correct na? Resultant force. So rate of change of momentum. Momentum is what? Mass time velocity. If I say this particle starts from rest with initial velocity u and attains the final velocity v in time t. Okay. So what will be the change of momentum? I can write m times v, correct, minus m times u. Is it correct? Hello.
Yes, sir.
And rate of change means it is what? Divided by t. And we know that these are vector quantities, so we can attach here vector. Okay. This will be, if you simplify, it will give you, see here, what you are going to get. This quantity, as you already know, let me do it fast because you already know this all. This you can see here. This will be the new quantity, that is acceleration vector, and which is nothing but what? The resultant force as per this discussion, correct? So what we can say here, we can also say that the rate of change of momentum of the body will be proportional to the resultant force of the body. That this is what? This is called the vector relationship. This is called the vector relations. This is called the vector relations. If you want to write it in scalar form, you can split this into a components. You can split it into a components. Okay. So scalar relations will be like this: summation fx max, correct? The x component, correct now? Summation fy will be nay. This will consider the motion in y direction. This will consider the motion of body in x direction. Similarly, summation fz will be m times az. This will consider the motion in z direction. But normally we are going to consider the coplanar system of forces. So normally we will deal with this much, these two components only. Correct? Hello? Hello? Are you getting me? So these are what? Scalar relations. These are what? Scalar relations. Correct now? Hello? Hello?
Yes, sir.
Yeah. Let me take one example. Suppose if this is your block, okay, let's say इसका जो mass है, let's say 10 kg, okay, and let's say यहाँ से मैंने 100 न्यूटन का फोर्स अप्लाई किया और यहाँ से मैंने 50 न्यूटन का फोर्स अप्लाई किया. It is resting on a horizontal surface which is being frictionless. Okay, there is no friction. Okay, so as per my coordinate axis, this will have my x and y axis. Okay, now as per what? As per Newton's second law of motions. Okay, what I can write here, since the body is performing, okay, since the body is performing a motion, correct, and the body will perform the motion in which directions? See here, as you can see from the diagram, okay, there is a 100 Newton force which is being applied from the left side and 50 Newton force which is being applied from the right hand side. Okay, so there will be a resultant force which will be not zero. Okay, so वो resultant force कितना होगा? We can find it out. Correct ना? And this resultant force will give the motion to the body in what? In x direction. Am I correct? This direction. Correct na? Are you understanding? This will be as ax. What will be the resultant here? 100 minus 50. 50 is opposite to the motions. If I consider this as my positive directions, this is my positive directions. So as per that, 50 will be minus. And this will be 10 times of A. If acceleration in x direction is A, so this will be 10 times A. Okay? So from here I can get what? A. That will be what? 5 meter per second square. Are you getting me? Hello? Hello?
Yes, sir.
What does it mean? This means the velocity is what? Velocity is changing at the rate of 5 meter per seconds. Correct? Means there is a change of velocity. Velocity in 1 second is 5 meter per seconds. It is changing at the rate of 5 meter per second. So maybe I can find out the velocity in 2 seconds, velocity in 3 seconds. Likewise, I can find out this. So this is sort of u plus at. Correct? So using this Newton's second law of motion, I can easily analyze the motions. Similarly, if I can reverse this problem, यहाँ पे मैंने क्या किया? I consider the force, okay, and using this force, I find out what? I find out the amount of the motions or the motion parameters. Similarly, this problem can be reversed. Let's say now, if the block is of 10 kg, okay, and if it is moving with an acceleration of 5 meter per second square, so I want to know how much is the force to be applied to produce this motion. That is, this should move with a is equal to 5 meter per second square, and with the same condition, that is mu is 0, is frictionless. Correct? So this is what, this is the first where we consider the force, okay, cause of motion was given, and we found the motion parameters. Now in the second case, we have the motion, and we want to find what? The cause of motion, that is P. So again, you can select your coordinate axis. This is x, this is y, and as per Newton's second law of motion, okay, this is what? Summation of x m times ax. So this will be nothing but P, and this will be 10 into 5, correct? So this will be 50 newtons. Are you getting me? That means the 50 Newton force is required in order to produce this much acceleration, that is 5 meter per second square. So in both the ways we can do the analysis. So this was about the Newton's second law of motions. Correct? Hello? Hello?
Yes.
Now, then why we need this D'Alembert's principle? Question
So can you
comes.
go to the last page?
एक second. Huh?
Yes, ma'am.
Now the question comes in mind, if we already have Newton's second law of motion, okay, then D'Alembert's जी ने क्या किया? Okay, and why D'Alembert's principle is required? Okay, so let us, before discussing this, let me tell you the limitations of this. That is the Newton's second law of motions. Okay. You might be knowing the what you might be knowing the frame of reference. Right? There may be two kind of frames. Okay, one is called inertial frame, and one is called non-inertial frame. Are you getting me? Hello. What is the inertial frame? Inertial frame is one which is not moving. Okay, that means its acceleration is 0, and that means velocity is what? Constant. And non-inertial frame means the acceleration is not 0 and velocity is not constant. It keeps on changing. Like, right? For example, let's say there is a lift. There is a lift. Are you getting me? Hello. Inside the lift, there is a mass. Okay, this mass, and it is being suspended with the help of a string. Okay, right? Hello. Hello. And now here there is an observer. Okay, let's say there is an observer which is looking this lift. Okay, this is observer A. Let's say. Are you getting me? Hello. This is case 1. Hello. And
Yes.
now let's say this lift is what moving in the upward direction with an acceleration A. Correct? Now what will happen here? See, if I will draw the free body diagram for this mass, okay, so यहाँ पे you can see what will be the forces which are acting on this mass. The weight, self-weight, that is mg, okay, and since this is a string, so there will be a tension produced in the string, that is T, correct? And since the lift is moving, okay, lift is moving with acceleration A, and the observer is looking here. Observer is on the earth surface, okay, observer is on the earth surface, correct? He is looking, he or she is looking the moving lift. This is what moving lift. ओके, तो जब ये यहाँ पे है, ऑब्जर्वर कहाँ पे है? ग्राउंड सरफेस पे, यू कैन से ग्राउंड पे है, एंड इफ ही इज लुकिंग टुवर्ड्स द लिफ्ट, तो लिफ्ट कैन बी सीन टू हिम एज अ मूवेबल लिफ्ट, करेक्ट? मूवेबल बॉडी. कैन, इज इट करेक्ट? हेलो, हेलो, right? And it can be seen like it is moving with the acceleration A, that is m times A. So here I can easily apply the Newton's second law. As per my Newton's second law of motions, what I will get? The summation F is equal to m A y, that is summation F y. तो यहाँ पे क्या मिलेगा मुझे? Just tell me. हेलो, क्या मिलेगा? If I assume again this my coordinate axis, what I will get here? I will get here T minus mg. Okay, the quantities in the direction of motions will be considered as a positive quantity. Okay, so see, lift is moving in the up direction, so T is positive, weight is in the downward direction, that is it is minus, and m times acceleration is a. Okay. So what I will get here? T is equal to mg plus m a. That means T is equal to m times g plus a. Is it correct? Hello, is it correct?
Yes, sir.
Let us consider the case 2, where now what I will make, what change I will make here. Now let us consider the same mass is what suspended in the stream. Okay, and again the lift is moving with acceleration here. But now what I make, ये ऑब्जर्वर अभी खुद के यहाँ पे आ गया, लिफ्ट के अंदर आ गया अभी. Let's say now the observer is here in the lift, inside the lift. Okay, तो ऑब्जर्वर के अंदर आने की वजह से क्या हुआ यहाँ पे? Can you tell me? Now he or she is not on the earth's surface, so he or she is moving with the lift. This body is moving and observer is also inside the body. So since the body is moving but the observer is inside the body and it is in the moving body, so he can see the body as at on rest, because what, because now here I had told you this observer will act as a non-inertial frame, because he is what, he is also moving with some acceleration. That means इसका acceleration zero नहीं है and velocity जो है constant नहीं है. समझ में आया ना? तो उसको क्या होगा, ये बॉडी क्या होगा, रेस्ट पे दिखेगा. क्या होगा, रेस्ट पे दिखेगा. दैट मीन्स अगर मैं यहाँ पे इसका फ्री बॉडी डायग्राम बनाऊंगा, तो अगेन आई विल हैव टी mg. Okay, and here acceleration you can see as 0. तो अगेन अगर मैं अप्लाई करूंगा न्यूटन सेकेंड लॉ ऑफ मोशन. Okay, are you getting Newton second law of motion? What I will get, summation Fy is equal to ma y. What I am going to get, this is the direction of motion, so this will be T minus mg is equal to 0, and simply I will get P is equal to mg. Now see, in both the cases the structure of the problem is same. Body is moving in the up direction, with the same acceleration, mass is same, string is same, only I changed the position of this observer. Here it was on the ground, here it is on the inside the zip. That means इस केस में ये क्या था, ग्राउंड पे था, इसका एक्सीलरेशन वगैरह 0 था, वेलोसिटी कांस्टेंट था, it was not moving. That means it was acting as an inertial frame of reference. Are you getting me? So I got this result, and when I change the position, I got this result. So which is to be considered as a correct one. So after so much analysis, it was found that experimentally that the results which was correct was this one, and this was a wrong result. तो अभी प्रॉब्लम ये हो गया कि इन दोनों में गलत क्या है, मिस्टेक्स क्या है, वो मिस्टेक्स फाइंड आउट करना एक इम्पोर्टेंट जरिया हो गया. आर यू गेटिंग? हेलो हेलो. तो यहाँ पे कंक्लूजन क्या निकल के आता है, कंक्लूजन ये निकल के आया बाद में कि न्यूटन सेकेंड लॉ ऑफ मोशन, ओके, न्यूटन सेकेंड लॉ ऑफ मोशन holds true only for inertial observer. मीन्स जो भी ऑब्जर्वर इनर्शियल फ्रेम के अंदर है उसके लिए ये सही है, अदरवाइज आपको रिजल्ट क्या मिलेगा, ये गलत देगा. तो अभी इसको सही कैसे करना है, अगर ये इनर्शियल फेज में जो ऑब्जर्वर है उसके लिए सही है, तो नॉन इनर्शियल फेज में जो है उसके लिए भी सही आना चाहिए। तो इसको सही कैसे करना है? तो इसको सही करने के लिए देयर वाज अ मॉडिफिकेशंस व्हिच वाज डन, एंड दैट वाज with the help of, it was found that experimentally there was some kind of pseudo force. What? Pseudo force. तो वहां से हुआ बर्थ pseudo force का। That means यहाँ पे अगर हमने एक इमेजिनरी फोर्स अप्लाई किया और ये रीडिंग को करेक्ट किया, जो टेंशन का रीडिंग आ रहा है यहाँ पे करेक्ट किया, तो ये रिजल्ट और ये रिजल्ट दोनों मैच करेगा। और इससे ये पता चलेगा कि when the observer is not under inertial frame of reference, so there must be some kind of pseudo force which is acting on the body, okay, so that Newton's second law of motions will be correct for that frame of reference. And that was done by the D'Alemberts. Okay, so let me tell you now what is pseudo force. Okay, this pseudo force is also called as, actually this is nothing but imaginary force. Okay, imaginary force. This is also called as inertia force. Inertia force. Okay, you can represent it as Fi is equal to, this force is what? This force is always applied in the opposite direction of the motion. अभी देखो यहाँ पे जो मैंने ये लिफ्ट का प्रॉब्लम बताया, अभी इसके अंदर क्या है, mg है ना, ये mg को मुझे क्या करना है, mg प्लस a करना है। तो इसको करेक्ट करने के लिए मुझे क्या करना पड़ेगा, इसके अपोजिट डायरेक्शन में, सिंस द बॉडी इज मूविंग हियर, लेट्स से now this was my problem, observer was here, okay, and this is my mass, okay, this is t, and body is moving in this direction, okay. So since it is having the acceleration in up directions, so according to pseudo force, okay, or inertia force, the body should go in the downward direction, and that's why एक force ऐड किया जाता है that is in the opposite direction of the motion. This is the motion का direction. Okay, so pseudo force is applied in the opposite direction, that is having the same magnitude but it will act in the opposite directions. So that's why इसका direction जो होगा opposite होने की वजह से it is always minus times m square. This is called as a inertia force or pseudo force. Okay, so body के अंदर, okay, body के अंदर क्या किया जाता है, जितने भी फोर्सेस है सिस्टम्स में, जितने भी फोर्सेस हैं, अगर उसको इस इनर्शिया फोर्स के साथ ऐड किया जाए, okay, तो बॉडी क्या आता है, एक डायनामिक रेस्ट कंडीशन में आता है, डायनामिक इक्विलिब्रियम कंडीशन में आता है, इसमें आता है डायनामिक इक्विलिब्रियम कंडीशन में आ जाता है, in the state of dynamic equilibrium. Okay, you might be knowing the static equilibrium. Static equilibrium क्या होता है, the body is not moving, here the body is moving but it is under state of dynamic equilibrium, means यही जाके आगे क्या बना, D'Alembert's principle. तो उसका स्टेटमेंट क्या आया, उन्होंने क्या स्टेटमेंट दिया, a system of forces acting on a body in motion, on a body in motion is in dynamic equilibrium, okay, with the inertia force, with the inertia force, and this was called as the D'Alembert's principle का statement. D'Alembert's principle का statement. The system of forces acting on the body in a motion is in dynamic equilibrium with the inertia force. So when you will add this inertia force, that system will bring system. This is entirely a system. If I consider this as a one system, okay, what are the forces acting on this? Summation of F कितना है, बोलो मुझे क्या क्या आ रहा है summation of F यहाँ पे, just tell me. T, body is moving in the up direction to T minus mg. This is my what? Hello. This is my system summation of systems of forces, correct? And now what I will do, I will add to this the inertia force, that is minus ma. So this will be becomes under dynamic equilibrium. So that will be 0. So what I will get, T minus mg minus ma will be 0, and hence I am going to get mg plus ma, which will be nothing but m times g plus a. Now you can see the same result we got, which we got earlier in the case 1 here. Is it? So that means this was nothing but just Newton's second law of motions with slight modifications, and it was known as the D'Alembert's principle. So it was what? Slight modifications done by the D'Alemberts. You understood this? Hello? What is pseudo force ka concept and what is D'Alembert's principle? Huh? Hello? Hello?
Yes, sir.
Yeah. Let us now consider example. I will write the equations using both Newton's second law of motion and D'Alembert's principle. Okay, so that you will get more understanding. Let us consider a basic example which you might be knowing. Let us suppose there is an inclined plane. There is an inclined plane, okay, which is kept. There is a block kept on this inclined plane. Let us suppose. Okay. Just a minute. मैं ऐसे बनाता हूँ. Okay, let us suppose this is my inclined plane. Okay, and here this block is kept on this, okay, having some weight. Okay, so I will have my coordinate axis. Okay, these are my coordinate axis. This will be x and this will be y, correct? If I consider the coefficient of friction between the block and the surface, okay, that is mu k, that is kinetic coefficient of friction. Okay, so mu k is what? Kinetic coefficient of friction. Okay, now I know that what are the forces which will be acting on this. If this block is having mass m kg, okay, so first I know what will be the force, that will be my weight, correct? This will pass through the CG, that will be mg, correct? And if this is an angle theta, I can resolve this into its components, correct now? Hello. So there will be one component that will be parallel to this, and this is another one, right? Hello. Are you getting me?
Yes, sir.
This will be, since this angle is theta, so this will also be theta, correct? So this will be mg, okay, sine theta, and this will be mg cos of theta, okay. And you know that since the block is kept on the inclined plane, so there will be some normal reactions which is being offered to this. This will be, let us suppose, this n, okay. So these are what the forces which are found to be acting on this, okay. And now let's say the body is what, sliding in the downward directions by default. नीचे की ओर ही जाएगा ना. So if it is moving in the downward directions, the friction force will be acting. Okay, that will be kinetic coefficient of friction times normal reactions, and that directions will be what? Directions will be opposite to the direction of the motions, correct? It will be like this, correct? In this directions. Am I clear? Now I can frame the equations of motions using both Newton's second law of motions as well as D'Alembert's principle. Okay. So if I use Newton's second law of motions, what is Newton's second law of motions? That is summation effect is equal to m times ax. Correct? Right? Hello.
Sir.
Yes. Now the body is performing the motion in this direction. Correct? This is my direction of motion. This is what? The direction of motion. So according to this, the quantities in the direction of motion will be considered as positive, and opposite to that will be considered as negative. So this will be mg, right, sine theta, correct, minus mu k times n is equal to m times, and let's say body in the x direction have acceleration ma. This is my equation 1, correct? Hello. And I know that summation fy is equal to ma y, correct? Are you getting me? Hello. Hello.
Yes, sir.
So in y directions, what are the forces? That is n and minus mg cos theta, and m into acceleration in y direction is 0. So there is no acceleration. That means n is equal to mg cos theta. This is my equation number 2. Correct? Are you agree? This is what as per Newton's second law of motion. If I want to frame, I will get these equations. Similar equations I should get with this D'Alembert's principle as well. Now let us see. So as per D'Alembert's principle, what it is saying, according to D'Alembert's principle, if the body is performing the motion in these directions, so there should be what? There should be an inertia force which should act in this direction, and that will be same in magnitude, that is m times a. Correct? This is inertia force. Correct? According to D'Alembert's principle, this is Fx, correct, minus max, that will be 0. तो कोई change आया यहाँ पे? Because Fix will be same. See, D'Alemberts ने क्या किया? सिर्फ न्यूटन्स का सेकंड लॉ जो था, समेशन F इज इक्वल टू m टाइम्स a, ठीक है? तो ये क्वांटिटी को उन्होंने क्या किया? यहाँ पे लाया, ठीक है? Are you getting me? This is brought on the left hand side and equated to 0. और फिर बाद में इसको क्या बोला उन्होंने? इसको उन्होंने क्या बोला? इनर्शिया फोर्स. Are you getting? Hello. So similar thing here. यहाँ पे सेम मिलेगा, फिर से आप लिखोगे तो mg sin theta minus mu k n and minus ma is equal to 0. Both are same. I hope you are getting. Hello. Similarly, summation fy minus may is equal to 0. That is n minus mg cos theta minus m times 0 is equal to 0. So this will be mg cos theta. Correct? Hello? Hello?
Yes, sir.
So I hope now you must have got the idea about Newton's second law of motions and D'Alembert's principle. Correct, na? समझ में आया ना अभी? तो you can solve the problems by using Newton's second law of motions, as well you can solve the problems by using D'Alembert's principle also. Okay, both the methods you can apply. Okay, if it is not mentioned in the question, if nothing is mentioned, but if it is specifically mentioned, solve using D'Alembert's principle or solve using Newton's second law of motion, then you have to use that particular method. Okay. Okay.
Yes, sir.
Yeah. Now, before going to the numerical, there is one more thing which I want to discuss, that about the motions. Okay. So while you are going to deal with the problems, okay, you may find that the problems can be given. Okay. Problems which will be given to you, kinetics का, may have a dependent motion, may have a dependent motion, and it may have a independent motion. Okay. So both the problems may be given to you. Okay. Both the problems can be given to you. Okay. What is dependent motion or constrained motion? Okay. In case of dependent motion, okay, or you can say the motion of connected bodies. Motion of connected bodies. Motion of what? Connected bodies. Are you getting me? So motion of connected bodies means what? The motion of particle is dependent on the motion of another or several other particles in systems. Okay. Motion of one particle. Okay. Motion of one particle is dependent on motion of another or several other particles in the system. Okay. So you have to first identify the given problem is of dependent motion or independent motions. The particles which will be given in dependent motions, okay, these dependent motions are formed by using usually they are connected to each other by one or more ropes or strings, you can say. Ropes या strings से connected रहेंगे, ठीक है? So they may be connected in such a manner that motion of one of the particle will affect the motion of the other particle. So analysis of such motion can be done by what? Establishing the relationship between the position coordinates. Okay. तो यहाँ पे क्या करना है अपने को? We can establish the relations between the position coordinates, and then once you relate these position coordinates, then you can differentiate to get the velocity. Okay. differentiate to get the velocity, because you know that position coordinate x, you can differentiate and you can get velocity. Again, if you differentiate, you will get acceleration. That is A. Correct? So we'll see that in the example. Okay. There are two different methods by which we can achieve this. Okay. One is called a constant string length method, and one is called as a what? Virtual work principle method. Virtual work principle. We can do this by both the methods. Let's say for an example, if I give you this particular example, let's say यहाँ पे अगर मैं बोलता हूँ आपको see here, hello, are you getting? Hello students, can you see this?
Yes.
Just a moment. Let's say this is 50 kg. This block is of 50 kg, okay, and this is 150 kg. Okay, so here if I tell you determine the tension, okay, in the string, and accelerations of two blocks of mass 150 kg and 50 kg connected by a string and a frictionless and weightless pulley as shown in figure. Is it clear to you? Hello? Hello?
Yes, sir.
And this one is fixed. This one is what? Fixed. So here you can see, first you have to identify whether this motion is dependent or independent. Based on that, you will solve the problems. So in this example, this you can see there is one block of 50 kg, okay, which is being connected to the pulley, fixed pulley. This one is a fixed pulley. Okay, this fixed pulley, and this is what movable pulley. You can see here, right? No, are you getting me? Hello. Now the motion of this 50 kg block will affect the motion of this 150 kg block. Am I right or not? So this can be treated as a dependent motion. Hello. Hello. Is it clear? इतना समझ में आया आपको? आइडेंटिफाई किया आपने?
सर वापस बताओ।
ये 50 kg का ब्लॉक या 150 kg का ब्लॉक, इसमें से जो भी एक मूव होगा तो दूसरे वाले को इफेक्ट करेगा कि नहीं करेगा?
हाँ ओके सर, समझो।
See here, the motion of one of the bodies or one of the particles will affect the motion of the another particle. So मैंने क्या बोला? If it is like this, so this will be considered as a dependent motion. That means it is a dependent motion. तो dependent motions के लिए पहले हमको क्या करना पड़ेगा? उनका positions coordinate के बीच में हमको relations frame करना पड़ेगा. Okay. That means उसके accelerations के बीच में हमको frame करना पड़ेगा relations. Okay. तो अभी यहाँ से इतनी सी बात क्लियर है. This 150 kg block, due to gravity, it will move downwards. Am I correct or not? So once it will be moving downward, this 50 kg block will move upward. Correct now? Are you getting? Hello? Hello?
Yes, sir. Yes, sir.
The block is connected to a fixed pulley, which is what frictionless, weightless. Okay, with the help of a string. Okay, the same string is passed over the another movable pulley. Okay, and it is connected to the fixed reference. तो दोनों एक ही कॉर्ड से कनेक्टेड है, एक ही स्ट्रिंग से कनेक्टेड है या नहीं? राइट ना? अभी इस वाले में टेंशन कितना आएगा? टी आएगा. करेक्ट? इसमें टेंशन कितना प्रोड्यूस होगा? टी होगा ना? इसमें भी सेम टेंशन रहेगा. आर यू गेटिंग मी? टी. हेलो. Hello. Now here the tension will be T, same. But this point, what will be the tension? This T and T, this will be 2T. Correct? You getting me? So, first method क्या है? First method. Now see, अभी tension तो पता चल गया. क्या दोनों भी bodies का acceleration same होगा क्या?
नो सर।
No.
No, sir.
दोनों का टेंशन अलग अलग है. दोनों में टेंशन इंड्यूस जो हो रहा है अलग अलग है, इसलिए दोनों का जो एक्सीलरेशन होगा वो अलग होगा. तो उसको हमको कैसे निकालेंगे? हम कैसा है? तो सी, उसके लिए दो मेथड है. पहला है वर्चुअल वर्क प्रिंसिपल मेथड. वर्चुअल वर्क प्रिंसिपल मेथड. Okay. According to virtual work principle method, work done by the internal forces will be considered as zero. The sum of the work done by the internal forces will be considered as zero. And tension here is considered as an internal force. Are you getting me? So tension is considered as an internal force here. So इसका मतलब work done by the tensions in all the two bodies will be considered as zero. So let us consider this first body. Okay, this is 50 kg. So इसका जो है tension is in this direction. Tension is always away from the point. And ये वाला जो body है, this is tension is what? 2T. Now we know that it is moving in the if direction is not known, we can assume it. Okay, if it is already known, then consider that direction here. Okay, and it is in this direction, right? So let us assume that इसका जो displacement है, this is delta y, or simply सिंपली एज्यूम करो उसका जो डिस्प्लेसमेंट है y है और इसका जो डिस्प्लेसमेंट है x. Now can I write you have done by this body, this first body will be t into x, correct? Actually work done क्या होता है f dot s, correct? And this is fs cos theta, correct? तो यहाँ पे क्या हो जाएगा, थीटा इज एंगल बिटवीन देम, तो यहाँ पे t bar dot x bar हो जाएगा, that is t x cos theta, and since the both are in the same directions, correct ना? So that means angle will be 0, so tx cos 0, this will be what, tx, तो ये प्लस आएगा. Are you getting me? Hello. So this is work done by this body, and similarly this wala, can you tell me? The second wala देखो 2t bar dot y bar, and the angle between them, they are in the opposite direction, so this will be 2t y cos of 180. Cos of 180 is minus 1, so this will be minus 2t y, and add this, okay, add these two quantities and equate it to 0 as per the principle, right? So this will be tx minus 2ty is equal to 0. इतना क्लियर हुआ? हेलो हेलो हेलो.
Yes, sir.
Yes,
Now
sir.
to simplify, what you are going to get, x tx 2ty, and this tt will cancel out. From here you will get x is equal to what, 2y. This is what the relationship between their position coordinates. Now what you can do on the next page, x is equal to 2y, differentiate this with respect to time, so you will get dx by dt is equal to 2 dy by dt. Now, dx by dt is what, rate of change of displacement of the first particle, that is what, v, or you can say v1 for first body. This is what, let's say v2, this is v2. Again, if you differentiate with respect to the time, you are going to get acceleration, right? dv1 by dt is equal to 2 dv by dt. You will get acceleration of first body is twice of the acceleration of second body. So see here, you got the relationship between the acceleration of these two bodies, correct? Now once you got the acceleration ka relationship, you can easily solve. Just frame the free body diagram and find out the equations of motions, and then use these conditions and get the results. Okay, so this is the first method by which you can get the motion parameters ka relationship. Second method is CSLM, that is constant string length method. Okay, I will tell you that tomorrow, or sorry, in the next lecture. Okay, so ये first वाला समझ में आया?
सर वो डायरेक्ट सबमिशन tx0 किया तो चलेगा कि स्टेटमेंट लिखना है लॉ का पहले?
नहीं, नो नीड, डायरेक्ट किया तो भी चलेगा, एग्जाम में ऐसा कुछ ये नहीं है कंपल्शन, ठीक है? ओके.
यस सर.
In other words, you can say that the product of the, see that virtual work principle, indirectly I can say the product of tension and accelerations in the two bodies or all the bodies should remain constant. That also holds the two ना same conditions. तो अलग अलग तरीका है, ठीक है? तो one can state like virtual work principle के तरीके से, और वही virtual work principle को modify किया तो tension into acceleration का product हमेशा constant आना चाहिए. ये fundamental पकड़ के भी चलेंगे तो same आएगा. समझ में आया ना? अभी इसके आगे का हम लोग नेक्स्ट लेक्चर में देखेंगे. जस्ट मुझे रिमाइंड करना, ठीक है, जहाँ पे रुका हुआ था. और अभी आप आगे का सॉल्व कर सकते हो तो करो, ठीक है? एक्सेलरेशन और टेंशन कैलकुलेट करो, फ्री बॉडी डायग्राम बनाओ. पहला प्रॉब्लम है तो दोनों से करो, न्यूटन सेकंड लॉ ऑफ मोशन से भी इक्वेशन निकालो और डी एलम्बर्ट से भी निकालो, ठीक है? और देखो सॉल्व करो इक्वेशंस क्या आता है एक्सेलरेशन और टेंशन का वैल्यू, ठीक है? फिर वो जो सेकंड वाला मेथड है वो यूज करके आप कैसे रिलेशंस फाइंड आउट करते हो एक्सेलरेशन का, वो कोई बड़ी बात नहीं है, वो आई विल टेल यू इन द नेक्स्ट लेक्चर. ओके. But generally follow the this virtual principal method. This is easier. You can apply this anywhere. Okay. But वो जो constant string length method है बहुत बार उसमें confusion होता है तो there may be a chances of error. Okay. So I will recommend this method only. Okay. But फिर भी मैं आपको बताऊंगा वो. ठीक है. Is that clear? Anything you want to ask? Hello. Should I record the attendance now, or you want to ask anything?
Attendance.
Attendance ले लो.
Okay, fine. Just a moment. Okay, attendance हो गया है. Now you may leave the meeting. Okay, thank you. So we are meeting on Friday, okay, for the next lecture. Thank you. You may leave the meeting. Thank you.